Hi and a very good evening. Introducing myself, I am Ahmad Shafirul bin Khairul Noah under the supervision of Dr. Muhammad Azwan for FYP1. So for today, I would like to present my proposal defense for a project entitled Volumetric Cell Production Prediction Study for Turkmenistan Field using coupled DEM and CFD model. So let us begin with the agenda and outline for the proposal defense. First off, I'll start with the introduction, which consists of background study, problem statements, objective and scope of study. Then we will move to the literature review, followed by the research methodology, project activities, and key milestone. Last but not least, I'll end the presentation with a conclusion and Q&A sessions. First off is the background of study. According to Rahmati 2013, he stated that the impact of sand production on the world production and facilities. Okay, so for example, the failure of sand control completions, pipeline erosions, surface facilities erosions, and the plugging of perforation or production liner, which would impact our well productivity. So one of the key factors for sand production is the low strength formation, which is due to weakly consolidated rock. So if there are any significant changes in the geomechanics or hydrodynamics forces of the formations, then the sand production would start to begin. So how do we know when the sand production will initiate? In general, there are two most common sand production onset model, which are Mohr-Coulomb model and Drucker-Prager model. There are other sand production onset model as well, such as EPS, von Mises, and etc. And so the main purpose of the study is to develop sand production model using Turkmenistan field as a case study. Next is the problem statements for this project. There are three issues that we would like to tackle throughout the projects. So the first one is the disadvantage of finite element modeling software. So in general, FEM software is employed to simulate rock formation based on continuum approach. However, this would cause us to neglect the discontinuum phenomena of real world, such as fracture or cavities. This obviously will affect the model as cannot simulate the phenomena. So in general, the FEM model, the elements in it are assumed to be connected to one another only at interconnected joints known as nodes. Elements are modeled as a small regions, not as a separate entities, and no cracks or surfaces between them. So in general, it can only simulate a continuum model. And then the second one is the disadvantage of DEM software if you use it as a sole simulation. This is due to DEM not considering the hydrodynamic force on rock matrix. It only considers the particle-particle interactions and not the particle-fluid interactions. So for example, the hydrodynamic force such as seepage drag force is not considered, although it is really crucial to the sand production, especially to weakly consolidated formation, according to Zhao, Yu and Choi 2011. As such, when DEM only considers the geomechanical effects on sand production and neglecting the hydrodynamic effects, does not simulate the real world situations. The third one is in understanding the sand transformation phenomena. According to Tromvold et al., the transportation phenomena of sand production depends heavily on the mobilization of grain particle by hydrodynamical or gravitational forces. The models that are employed today, such as FEM, would need to have an assumptions to consider the hydrodynamic effects. And meanwhile, for DEM, it would neglect the hydrodynamic effects altogether. As such, by coupling DEM and CFD, geomechanics and the hydrodynamics forces effect on the world would be considered. Next is the objective of the project. So the first one is to develop the 3D modeling of perforated formation using EDM. So basically EDEM is a bot simulation software based on DEM numerical method, and it is usually utilized to simulate and analyze the behavior of geomechanic related material such as soils, rock, and others. The second objective is to evaluate the volume of sand production by coupling the computational fluid dynamics CFD and discrete element model DEM. So next, I'll brief to you on the scope of study for this project. And so for the first objective, which is the development of 3D modeling of perforated formation, the project would focus on a single perforation only, as well as considering the type and size of formations. This also includes covering a range of sand particle dimensions. Then for the second objective, which is the evaluation of the volume of sand production by employing hybrid methods. So the parameters that would be covered are in situ stress on the formation, such as triaxial stress and biaxial stress, stirring of rock, and fluid flow that are involved in this study. So the fluid that would be considered are oil and gas. And then apart from that, formation size would be taken into consideration as well. And last but not least, the case study for this project are the Turkmenistan field. So we would use the data from the Turkmenistan field to model the 3D perforations. Okay, so now we have come to the literature review section of the presentation. So the two common models that are generally accepted and widely utilized for sand failure onset are Mohr-Kohler model and Drucker-Prager model. So according to Papamitsos and Furui, the key factor in Mohr-Kohler model is the effective stress at borehole or perforation. So they use the effective stress at borehole and perforation to determine the sand onsets. And then other than that, we also have the Drucker-Prager model. So it is in general is a pressure dependent model. So it is used to investigate the plastic yielding at rock matrix in order for us to determine the failure of the formations. There are several mechanisms which contribute to sand production. For example, for the geomechanic force, we have the drawdown pressure, we have the failure of shear and tensile stress, plastic strain and pressure gradient. And meanwhile, for the hydrodynamic force, we have the seepage drag force by the liquid flow. According to Zhao et al. 2011, sand particles which have been disintegrated from the formation would be transported by hydrodynamic force such as drag force and buoyancy force of the liquids. Apart from that, how do we specify which formation would need a sand control? It has been specified by Choi et al. 2013 that formation with less than 500 psi unconfined compressive strength (UCS) would need sand control, and the formation which has UCS above 4000 psi would be unnecessary. However, there is a grey area that we need to take into consideration, which is in between the 500 psi to 4000 psi, and further study would be required. And there are three types of modeling for sand production. Basically, we have the lab testing and experimentation. So the lab testing and experimentation are usually used for calibration of analytical modeling and numerical modeling. However, we can still use the lab testing to predict the beginning or the onset of the sand productions, but it is only limited to that. Other than that, we also have the analytical modeling. So this one is basically a closed mathematical equations. Several parameters such as rock properties is considered in the model. So next we also have the numerical modeling. And the two most common one is the finite element modeling and discrete element modeling. So the advantage of analytical modeling is that it is simple and quick to apply since it is just mathematical equations. However, it has a great limitations in terms of parameters. And then for FEM model, the advantage is that it is less costly and required less time to simulate compared to DEM methods. However, the disadvantage is that it cannot simulate the discontinuous behavior of formations. And then lastly is the DEM model. So the advantage of this is its ability to capture the motion and interaction between individual particles. It basically means that it can simulate discontinuous behavior. However, we need to take consideration of its long computational period. It requires longer time to simulate compared to FEM methods. So for the DEM method, there are numerous studies that have been conducted on the approach. But for this proposal defense, I would like to focus on two main studies, which is the O'Connor 1997 and Zhao et al. 2011. So for O'Connor study on 1997, it is based on the DEM modeling for sand production during oil recovery, and for Zhao et al. 2011, basically this one is a study which combine or couple the DEM method with CFD method to account for sand erosion in the perforation. And the reason for the emphasization on both studies is because it is really related to the projects. And so for the boundary and rock formation criteria for the DEM simulation. So in summary, basically the rock matrix can be represented by an assembly of n-sided polygons. This is to mimic the complexity of each particle, since we have a particle which range from rounded to angular. And then the interaction and movement of particles would be modeled by constitutive law and Newton's second law, respectively. And lastly, to simulate the cementation, we apply parallel bonds to the model. So one of the main questions for this project is how are we going to incorporate both DEM and CFD model together? So according to Zhao and Sean 2013, it states that the DEM can be utilized to simulate the framework of rock particle, and the CFD can be utilized to simulate the flow of liquids. And the DEM approach would be solved by Newton's second law of motion, while the CFD would be solved by Navier-Stokes equations. So the Navier-Stokes equation is basically an extended version of Darcy law, but this one is the one that we consider the viscous force effect on the liquid itself. And the justification on the importance of fluid flow in sand production is based on the statement of Zhao et al. 2011, which he stated that the sand production is a phenomenon in which sand particles are produced together with fluids from the reservoir, and as well as the crucial role played by flowing fluid in sand production, especially in the unconsolidated or weakly bonded formation. So there are two previous studies on the coupled CFD-DEM simulation. The first one is by Zhao et al. 2011, and the second one is by Zhao and Sean 2013. For Zhao et al. 2011, basically the study on the focused on the erosion of sand particles, in which hydrodynamic force is induced by fluid flow, while for Zhao and Shan 2013, the study focused on the simulation of fluid particle interaction behavior in general. So now let us move on to the research methodology. So for the first step of the methodology is literature study, followed by the development of sand formation model in DEM. Then the next step is incorporating DEM and CFD model together. The next step is the analysis of sand production using the field parameters. So for the field parameters, the one that we are using is the Turkmenistan field. And lastly is the recommendation for future improvements. So for the literature review, basically the focus on the journal or article that is used in the project is we only considered the literature from 1990s to 2000s, as the one before 1990s is irrelevant due to technology. And then for the developments of self-formation model in DEM is based on several past studies such as Zhao et al. 2011, Zhu, Zhao, Yang and Yu 2007, and Fajar 2004. As mentioned earlier, Newton's second law of motions and constitutive law is used to model the particle-particle interactions, and apart from that, the rock matrix is represented by n-sided polygons, and parallel bonds are used to simulate the cementations. And then is the incorporation between DEM and CFD methods. So DEM is utilized to simulate the framework of sand particles, and CFD is utilized to represent the fluid flow. And as mentioned earlier, the CFD would be solved by Navier-Stokes equations, and the DEM would be solved by the Newton's second law and constitutive law. So by coupling both of the methods, we can simulate the particle fluid interaction of the model, such as the drag force and the buoyancy force effects on the rock matrix. And after that is the analysis of sand production using field parameters. So among the data that is required from the Turkmenistan field are the value of well pressure reductions below critical sand production model, fluid viscosity and flow rate, rock cementations, rock properties such as grain density, porosity, and etc. And then after the analysis is done, the data will be compiled and discussed further. So among the analysis that we would do for this project is the prediction on amount of sand that would be produced each day, as well as how much of the sand production that will accumulate throughout the oil recovery or gas recovery. Finally is the recommendation for future improvement. So in general, improvisation and the continuation of the project would be recommended at the end of the project itself. So this is for the future or for the continuation of the project itself. And then I'll brief to you on the key milestone and project activities for this semester. So basically, the key milestone or the activities for this project in this semester are identification of related previous study and methodology, preparation for DEM CFD methods, such as the formula and all that, and lastly, to design a suitable modeling methods using EDM. And finally, we have come to the conclusion section of the presentations. In general, the conclusion would reflect the objective of this project. So one of the expected results from this project is the 3D model of perforated formation using DEM. And the general condition is based on previous studies such as Zhao et al. And the literature review that I've mentioned earlier. And then the next expected result is the utilization of hybrid DEM CFD to simulate the project. As mentioned before, DEM will be employed to simulate individual grains in the formation, while CFD would be utilized for fluid flow modeling. So that's all from me.